Today I'm going to explain a bit more about programming and C. So in C, you usually have a file name, which is whatever the name is, and the extension .c. That means that it's a C source code. The source code is basically the readable version of the code, human readable version of the code. So things that are written with actual human words. The source code has a simple job, which is for us as humans to tell the machine what to do, how to operate. And in C, you always start with a main function, right? The function is main. You have the two brackets here, so int main, two brackets, and then you have curly brackets. Inside the curly brackets is where you have to put your code, where you declare data types and where you write the logic of the code if it shows anything on the screen, if it does any processing to calculate a number or to find any data, or and when it gets information from the user, whoever is using the program you developed. Int right here is just a return type. So at the end of this program, you have to have return 0. And that just says when this program reaches this is the end of it. This is the end. This is where your program stops. So I'm going to go over some data types today. So for data types, you have ints, right? These are integers, and then you put a name for your data type, which I'll put as A, and then a semicolon. In C, you always have to end each line of code with a semicolon. Um, there are a few data types in C. I'm going to see if I can just let you know the size of this data type right now. Just trying to find that information. So if you use an int, you get a pretty big number. You can basically go from positive 2 billion to negative 2 billion. So in integers, ints, okay, so a double slash is a comment. So you have -1, -5, 0, 5, 10. So you can go positive and negative, but it has to be a whole number. Then next you have a float. The float is B. That's just going to give a name, semicolon to end my line of code, and then I'll add a comment. And a float now is any decimal. Basically, you want 4.4, right? Negative 5.5, 0, or you could just name it 0.0. You can have 0.555. Forgot the dot. Yeah, that has to be called. And then you have a double, which is very similar to the float, except that it's more precise. So you could say, for example, 4.12345678987654321. It's very precise and it goes on for quite some time after the decimal point. So if you're working with anything scientific that requires that level of precision, you'd more than likely go towards a double. That's because even if you do a calculation, you save it as a float, the float will round it up to what its maximum precision is. The next thing now is when you're working with strings. Strings are like words. For example, I'm gonna add a comment right here. Apple. There are two ways you could do this. So you have char, which is a data type in C that holds characters. So char D is equal to, when you're writing a character, it has to be single quotation marks A and then a semicolon to end the line. So this is saying that my data type D, which is of type char character, holds the letter A. And then if I want P, I basically do the same thing again. So char, I can't have two data types, two variables with the same name. So char E is equal to P, and that holds the letter P. But it would be kind of annoying for you to do that for each letter. So the way that you usually get around this in C is that you have char asterisk and then the name of the data type, so D, and then you change this single quotes to double quotes, and you can have apple, the whole letter, the whole word, the whole string, and this is how you store it. And this is it. So what happens is in C, which is very important, it stores it as a letter P with a letter A with a letter P with another letter P with a letter L and then E. And at the very end of that, it adds on a null character. So this /0 is a null character that's put at the end of every string in C, and that's very important when working with strings. When you declare it up top here, you don't have to put the /0 because the compiler, they turn this into machine code, recognize that this is a character and it adds it automatically for you. But in other cases, you will have to add this manually. And then let's say I wanted to print out whatever what variable D is storing. I would have the function printf, which I assume stands for print formatted. Then I have double quotation marks inside, and I will add %s. So that's a placeholder for the character. So %s means that you want to put a string at that location. And then outside the double quotation marks, I put a comma and I put D. So D is what I want to appear wherever I put %s in my printf statement. And I end that with a semicolon. So printf is one of the built-in functions in C. I can only use these built-in functions in C. So to get printf, I have to run #include angle brackets stdio.h. stdio.h, I believe, stands for standard input output header file. And header files are just the files that you include into your C program whenever you build one, whenever you write one. So if I was to compile and run this, I should see the word apple appear in my terminal. Let me actually do that. I am compiling this in Linux, so I think if you do it on a Mac or on a Windows, there's a different way to see it. I'm just going to show you what the output of the program will be. So in Linux, I go gcc, and the name of this file is data types.c, capital T there. And I compiled, no problem. If there was an error, it would have told me that I probably misspelled something. And then I'm going to run it. And just like that, you can see Apple right here. So it works, and my program compiled. All right, I'll be going over some more in my next video.